Hi, wanted to record the answer to essential question number 3, version 1, for the summer of 2011. This is what your essential question should have looked like. It's set up in the usual way where asset A is this guy that goes all the way across. Again, it costs you 22 in time period 0, and then it gets you 31 in time period 2. Present worths are already calculated for you, and you have to calculate internal rate of return, but these incremental internal rates of return are all calculated for you. So let's go ahead and first start with question 1, which is what is the internal rate of return of asset A? This is one of the easy ones. We just go ahead and say, well, the present worth of asset A is this when the interest rate is a variable, and then just solve for the interest rate that makes the present worth 0. What I did was spotted that your only benefit is in time period 2, your only cost is in time period 0. And so if you do the little rearrangement, you have a shortcut which just says that if you take the ratio of time period n benefit and you put it over the time period 0 cost and take it to the square root of 1 on the number of time periods that benefits in the future, subtract 1, and you should get the internal rate of return. In this case, we find one that's 18.71% approximately. That's the answer you should have. Question number 2 says, at a minimum acceptable rate of return of 10%, requirement to provide 12 years of service. That's the key phrase that says, hey, you need to use annual worth on this. Which asset would you choose? So what you have to do in this case is calculate the annual worth for each one of these assets. Present worth's already given to you, so that step doesn't need to be done. And you know how long these things live, even though you've got this space right here. So what you have to do is calculate the present worth of an asset that has, the annual worth of an asset that has a present worth of $3.62 and a life of $2. Present worth of another asset that has annual worth of an asset that has $3.52 present worth and a life of 3 years. And so all you're doing is doing the looking for A given P equation. So what you should try doing, look over here, here's the right equation. There's the present worth of asset A, 3.62, and this is the equation for looking A, given you know P, and the number of time periods is 2. And you find that it's 2.08581. You can do something similar for asset B, and this is one that has a present worth of $3.52, and it lasts 3 years, 1.41. Here's his similar thing for asset C, which has an annual worth of 1.68. This is something that lasts 4 years. And then asset D has a negative present worth that's hiding around right there. Oops, I have a little mistake right there. Look at that. Knew that didn't feel right. That should be right. Ding, 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 ding. 3.69. And if you look down on the key, hopefully I managed to get the exact same answers down at the bottom. 2.09, 1.42, 2.09, 1.42, there we go, 1.69, here we go, and the last one is 0.52, 0.52, oh, that's different again. Oh, time 4 periods or 3 periods, where is it? How long does that one last? It lasts 3 periods, so yeah, looks like I messed up a couple of things on there, so the 3's right there. There you go. Some things was looking. There you go. 5.2. So the idea with annual worth then in that case is that you just pick the one with the highest annual worth. And the idea is that you buy one of asset A, let it burn out, and get another one, and so on until you get up to 12 years. The one with the highest annual worth is asset A again. That's the one that has the annual worth of 2.09. That means on average you're supposed to have $2.09 worth of benefits every single year. Let's go down and move to question 3, which is usually the easiest one. And so this is at a minimum acceptable rate of return of 10% and no service requirement. Which asset would you choose? This one's easy. You use the present worth criteria. You pick the big one. The one with the largest present worth is asset C, 5.34%. Easy. The last one is the one where you have to use that procedure that only the engineers have to deal with. And the idea is that present worth can't be calculated again, because you don't know what's in this space right here. So there's all these things that, there could be like a negative $1 million here or something along those lines. So what you have to do is use that internal rate of return procedure to identify which of these assets is best. So remember that the internal rate of return on asset A is 18.71%. The first step of your procedure is to eliminate all assets that have internal rates of return less than your minimum acceptable, which is 20. So you know you get rid of A and you get rid of D, so that leaves you with only assets C and D. After that, you order the assets from smallest to largest, so you're going to test C first, and you're going to see if you should upgrade to B. So, given you're already at C, see if you should upgrade to B. You do this by taking a look at the incremental internal rate of return of B to C. That's highlighted right there. That's 91.71%, which is way higher than 20. And so you know that you're supposed to toss C, and B is your best asset. And that should be the solution to that one. Anyway, so this is the answer to essential question number 3, version 1 during the summer of 2011.